Hi everybody! In today's video, I'm going to be going through the notes for lesson 8.8, which is going to be all about multi-step equations. Now this is really the whole enchilada. This is the whole thing, and this is pretty much as complicated as equations can get. So let's go through the overall plan before we actually do any problems. Step number 1 for any equation is always going to be to check for parentheses and distribute if necessary. So if we see parentheses, distributing is going to be our first step. For example, in this first example problem, you're going to notice that there are parentheses on the left-hand side. So my first step here is going to be to distribute, which means I'm going to have 3x plus 12, and everything else is just going to drop down. My second step whenever I'm solving is going to be to combine like terms, but only if they are on the same side of the equal sign. We can't combine things unless they're already both on the left or both on the right. So I'm basically going to look at the left side of the equal sign separately from the right side of the equal sign. Now, if I look at the left side, I'm going to see that there actually are some terms that are like terms over here. There's a 6x and there's a positive 3x. Because they're on the same side, I can combine those and just get 9x. And everything else is something I'm just going to copy down. So the plus 12 and the 2x plus 37. Next, we're going to get the variables together. In our previous video, we talked about how if you have a variable on the left and the same variable on the right, you need to get them together. In this problem, we have an x on the left and we have an x on the right. So our next step would be to subtract 2x on both sides. Now, when I do that, I get 7x, and then the x's on the right-hand side cancel, and everything else just gets copied down. So plus 12 and 37. The last thing that we're going to do is we're going to solve by undoing the numbers, starting with the number that is farthest away from x. So in this case, I would subtract 12 on both sides, which means on the left-hand side, the 12s cancel. And on the right-hand side, 37 minus 12 is 25. Then I'm going to drop down the 7x. Then I'm going to divide by 7. Which means that on the left side, the 7s are going to cancel. And we get x equals 25 divided by 7 is going to be 3.57. Okay, now I know this is a lot of steps. But the good news is this is literally as hard as it gets. If you can master these 4 steps, you can do all of the really complicated equations. So let's do a few more examples just to make sure we follow the steps in the right order every time and that we can master those steps. For problem number 1 here, we're going to start by going through our checklist. Do we need to distribute? Because there are no parentheses in this problem, we do not need to distribute, so we're done with that part. Step number 2 is to combine like terms if they're already together on one side of the equation. So we're going to look at the left side first, which is the 8x minus 3x minus 10. And I can see that there are some like terms here. There's the 8x and the negative 3x. Together, when you combine those, you get 5x and we're going to drop down the minus 10 and the 20. There are no like terms on the other side, so we're done with that step. The next step is to get the variables together. Well, in this problem, there's only one variable and it's on the left, so it's already together with itself. The last step is to solve. So in this case, we would add 10 on both sides, and we would get 5x equals 20 plus 10, which is 30, and then we would divide by 5. And we get x equals 30 divided by 5 is 6. And we're done. Now again, these steps are the steps in which you think through a problem. It doesn't mean you always have to distribute or you always have to combine like terms. You just have to check to see if it's necessary. Let's try the next problem. We're going to draw a vertical line through our equal sign. Now we're going to check to see if we need to distribute. In this problem, there is a parentheses, so we are going to need to distribute. But the question is, what are we distributing? One thing we'd always want to remember is that if there's no number, there's always an invisible 1. So it turns out in this problem, we are actually distributing a negative 1, which gives us negative 2m minus 12. Then we're just going to copy down the 7m and the 23. Next, we're going to combine like terms. So 7m minus 2m are on the same side of this equation. So we don't have to add or subtract anything. We just have to combine them, which means I get 5m, and I'm going to copy down my minus 12, and I'm going to copy down my 23. Now I need to check to see if my variables need to get together. There's only one m in this problem, and it's already together with all the other m's, so we're good on that one. And the last thing we need to do is actually solve it. So we're going to add 12 on both sides, which means that we get 23 plus 12 is 35. Equals, and we're going to copy down the 5m, and then we're going to just divide by 5. So we get m equals 35 divided by 5 is 7. Okay, let's try a couple more. Again, these are pretty complicated problems, so let's just make sure we really got this. For problem number 4, we're going to start by drawing a vertical line through the equal sign. Next, we're going to check to see if we need to distribute. In this problem, there is a parentheses, so we're going to need to distribute, which means we get 3n plus 6. On the other side, we get 9n plus 12. Next, we're going to check to see if we can combine any like terms. In this problem, if I look at just the left side, there are no like terms. And if I look at just the right side, there are no like terms. So there are no like terms to combine. So now we need to think about getting our variables together. We've got n's on the left and on the right, which means we're going to have to undo one of them to get them to be gone on one side and move to the other side. That means that we can drop down our 6, and 9n minus 3n is 6n plus 12. Then we're going to subtract 12 on both sides and finish our solving. So on the left side, the 12s cancel, and we just drop down the 6n. On the right side, 6 minus 12 is negative 6. And then we will divide by 6 on both sides to get the n by itself. Now again, I understand these are very complicated problems, and that's okay. We can do really complicated things, but we do need to practice. Number 5 might look a little weird, so let's talk about it so you kind of have an idea of what's going on here. What you're going to notice in number 5 is that on the left-hand side, there's this big fraction. When that happens, it means that we're dividing everything on the top of that fraction by the number 4. So to simplify this, I would divide the 12 by 4, which is 3x, and then I would divide the 8 divided by 4, which is 2. Then I can just copy down the right side of the equation. Again, we're just going to divide everything. From here, it's the same thing we've been working on. So we're going to check to look for some like terms. If I look at just the left side of this equation, there are no like terms. And if I look at just the right side of this equation, there are no like terms. So I'm going to look at the x's being together. There is an x on the left, and there is an x on the right, which means we need to undo one of those x's to get them to be together. I'm going to subtract 2x on both sides. When I do that, the 2x's cancel, and I'm just going to drop down the -9. And I'm going to combine the 3x minus the 2x, which is 1x, and bring down the +2. Next, I'm just going to solve. So I'm going to subtract 2 on both sides, which means that I get the x drops down, and -9 minus 2 is -11. Now I could divide by 1, which is totally fine, but when we divide by 1, we just get the same answer we already had. So as a matter of fact, 1x is really just the same thing as x, which means we're done. All right, that's it for today's video. Thank you guys so much for watching, and good luck with solving these complex equations. I'll see you soon for some practice.